Welcome to Mathletes. I'm Gori, and today we'll be taking a look at simple interest versus compound interest. I'll be doing every question ever asked in HSC Standard 1 Maths over the last 5 years. So grab a pen and let's get started.
All right, this is simple interest versus compound interest, HSC Maths Standard 1, and these questions come up every single exam, so let's get into it. All right, Bobby plans to invest $25,000 for 10 years and is offered two investment options. Option A earns interest at a rate of 5% per annum, compounding monthly, and option B earns simple interest at a rate of 8% per annum. Which investment option will provide Bobby with the best return value at the end of 10 years? Justify your answer with calculations. All right, well, let's go ahead and figure out what Bobby will get with option A. So with option A, this one is compounding and it's compounding monthly. So we're going to use our formula. Final value is equal to principal value 1 plus r to the power of n. Okay, so now we need to be really careful about what our r and our n is here. Because it's compounding monthly, we need to take that 5% and divide it by 12. So 0.05 divided by 12 is going to equal our r. Okay, and let's see what that comes out to with our calculator. So 0.05 divided by 12 gives us 0.00416 repeater. Okay, and our n is going to be equal to, 12 months of the year multiplied by 10 years. So n is going to be 120, right? So now substituting those values in, we get our final value is equal to our principal value, 25,000, 1 plus 0.004166 to the power of 120. Right, so all we have to do is chuck that into our calculator and we'll get the answer. So I'm doing it to the power of 120 and then multiplying it by 25,000. All right, that gives us a value of 41,175.24. Okay, that's with option A. All right, now let's look at option B, and that's simple interest. So there our formula is equal to I PRT, where P is our principal value, that's 25,000, and our rate given is 8% per annum. We don't need to do anything to that, so we just put in 0.08, and then our time is 10 years. Because both our rate and our time is in years, we can keep that the same. All right, so we put that in our calculator, and we get 0.08 times 10 times 25,000. We get 20,000 in interest. Now we just need to be careful to add on the initial principal again. So our final value is equal to our interest plus principal. So 20,000 plus 25,000, which means we have 45,000 with option B. So which investment option will provide Bobby with the best return at the end of 10 years? Option B. Provides best return. That's it. All right, let's check the answer. Yes, Bobby should choose option B. Alex and June each invest 1,800 for 5 years. Alex's investment earns simple interest at a rate of 7.5% per annum. June's investment earns interest at a rate of 6% per annum, compounded quarterly. By calculating the interest earned over 5 years, determined who will have the greater amount. Okay, so let's go with the first option, option A, which is simple interest. So I equals PRT. So they're investing 1,800, that's our principal, and our rate for simple interest is going to be 7.5%. So that's 0.075 as a decimal. And then our time is going to be 5 years. All right, so putting that into our calculator, 1,800 times 0.075 times 5. So the interest earned is 675. And that's it for our first option and our second option. So this is simple. And then this is compound. So with compound interest, it's going to be final value is equal to our principal, 1 plus r to the power of n. Our principal is the same, it's 1,800. 1 plus. Okay, so now we have to do a bit of work on to find our r. So our r is going to be the 6%, but it's divided by 4, right? So 6 divided by 4, which 2 goes into 6 3 times, 2 goes into 4 twice. So 1.5% is what our r is, or in other words, r is equal to 0.015, right? Because we want to find out what our r is for each quarter of the year, not per annum, we want it per quarter. So we go 1 plus 0.015 to the power of, okay, so how many times is it going to compound? 4 times a year times 5 years. So n is equal to 4 times 5 equals 20. All right, so we've got that to the power of 20. All right, coming down here, we put that into our calculator, and we've got 1.015 to the power of 20. And then we multiply that by 1,800. Gives us 2,424. All right, now comparing these two numbers, so this is a final value with compound interest. If we want the final value with simple interest, we have to add 675 plus 1,800. And that gives us 800 plus 675. 2,475. We want to make sure that we're comparing apples to apples. So these are our final two numbers. Who's going to have the greater amount? Well, we can see that simple interest, 2,475, is greater than 2,424. So simple interest gives the greater amount. And that's Alex. Okay. Our answer, yep, Alex earns more interest. Yep, they got to 675 there as well. Great. Bobby invested $5,000. The table shows the progress of his investment over the first 4 months. What are the values of A and B? Okay, so we can see that the amount started off with 5,000 and it is compounded monthly at 0.6% per month. All right, so to get the value of A, all we're doing is we're taking this principal and we're applying the monthly interest rate to it. Um, and yeah, it's as simple as that. So I equals PRT in this case. So 5090.54 times the rate, which is going to be 0.006 times 1. So just putting that in our calculator, 5090.54 times 0.006. So the value of A is going to be 30.54. Let's check that. Yep, 30.54. And then B is the balance at the end of the month. So all we're doing is we're adding 5090.54 plus 30.54 to get our value for B. So putting that in our calculator, we get a value of B is 5121. Oh, that's a decimal point. 08. That's it. 5121.08. Bobby could have earned simple interest on the investment at 0.62% per month. How much interest would Bobby have earned over 4 months by choosing this option? All right, so I equals PRT. So our principal is 5,000. Our rate is 0.0062. They're being a bit tricky there because they put the percentage sign here, okay? So don't get caught out by that. 0.062 times 4 months, right? That's the rate per month. And then we just multiply it by 4 months. So putting all of that into our calculator, we get 5,000 times 0.0062 times 4 equals 124. That's it. All right. Peter has a choice of investing $7,000 in 2 different investment funds. Fund A is 5.2% per annum, simple interest. Fund B is 5% per annum, compounded annually. Okay, what is the difference between the amounts of interest earned in the 2 investment funds over 3 years? Okay, so let's go with the simple interest, which is A. I is equal to PRT. So our principal is 7,000. Our rate is 0.052. That's per annum. And so the time is 3 years. So we just multiply by 3. All right, putting that into our calculator. 7,000 times 0.052 times 3. We get 1092. That's how much interest we earn over the 3 years. All right, and then with compound, that's option B. It's going to be FV equals PV, 1 plus R to the power of N, which is equal to 7,000, 1 plus. Okay, so it's 5%, very straightforward, and the number of years is 3. So again, putting that into a calculator, 1.05 to the power of 3. And then we're multiplying that by 7,000. So we get 8,103,375. So this is our final value. And if we want to compare apples to apples, we have to actually minus out the principal from this. So the interest is going to be final value minus principal, which is 8,103,375. Take away that initial 7,000. So we're left with 1,103.3, call it 8. So we're doing that to 2 decimal places because it's money. And those are the two interest rates that you get with option 1 and option B. Now, the question said, what is the difference between the amounts of interest earned? Okay, so the difference, is going to be 1103.38, take away 1092. Okay, so we put that in our calculator, 1103.38, take away 1092. So the difference is $11.38. And compound interest. Fund B is higher. All right. 1138. And fund B is higher. Great. All right. James invests $5,000 at 3% per annum simple interest for 2 years, while Sally invests $5,000 at 3% per annum compounded annually for 2 years. Which of the following statements is true? Okay, so it's basically saying who is earning more with simple interest or compound interest, same interest rate over just 2 years. So I think a good way of looking at this is within the formulas, if we don't actually calculate it all the way to the end. So with the first one, I equals PRT. The principal goes there, 5,000. Now our interest rate, 0.03, and our time is 2. Okay, so if we look at this part of the formula, it's going to come out to 0.06, right? And if we compare that to the compound interest formula, so that's going to be f of v is equal to PV 1 plus r to the power of n. And so that's going to be 5,000, 1 plus 0.03 squared. Okay, so again, without multiplying it out, this part here, if we just calculated the little bit that's in the brackets, it's 1.03 and then squared. And so that comes out to 1.0609. All right. So as you can see here, the compound interest one is going to be slightly more. It's only 0.0009 more, but this part is going to be more than this part, right? With simple interest, we need to add the principal back at the end, so that kind of gives us that 1. But the difference between the two is this part right here, this crucial 0.9. So in this case, the compound interest person is going to earn more, which is Sally. So we can very confidently say that it's B. Sally earns more interest than James. And looking at the answer is indeed B. All right, that's it.